Hello class, thanks for tuning in, welcome back. Today we're going to jump right in here. We're going to be talking about matrices today, which I know is kind of a new topic. A matrix is a way of displaying data in certain sets where, it's usually used in computer sciences, like computers in general, how they store information in memory. Memory is established in rows and columns, so it's very organized, so it can call up stuff very quickly. That's basically what this is used for. So if you're going into some computer sciences, this is a massively important thing. But if you're not, it could be one of those things where it can help you in certain situations, like solving systems. And yes, there is a way of solving a system, which is something we did a couple weeks ago, but it is a way of doing it. But let's just talk about the basics. We will go into solving matrices, solving systems with them in the next couple videos. But let's jump right in. Let's talk about this topic today, and we'll kind of see what each of our topics are. So basic operations. So we're going to be just adding and subtracting. That's going to be our main focus. Then I'm going to introduce you to multiplying. Now that's going to be a big part of like the next video that we're going to do as well. It'll be multiplication, but there's two types of multiplication. There's a product of two matrices, and then there's a scalar multiplication, which is kind of like just taking a single number times an entire matrix. So it just kind of multiplies on everything. Sum and difference is super easy. Scalar multiplication is super easy because it's just term for term. You have to have matrices that are the same size. We'll go through what a matrix is here in a minute. And products, there's a rule to it. So we're going to look at that. And I'm going to try to stick with kind of an easier one because in the Google form, I didn't really give you any challenging ones yet. That'll be in the next video that we do. But let's jump right in. So a matrix, if you're not familiar, is a way of displaying data into like a grid. Now, I'm just going to start with the basics. So let's say this is a 1 by 1 matrix. So they put usually the dimension down in the corner, 1 by 1. So what that means is that there is one row. So this number means row. And there is one column. So one row, one column. So that means, if you're thinking about it, there is just a single number in here. One number, one row. So one row, one column. If this was, let's say that, I changed the dimensions here. Let's say that maybe this is a 1 by 2 matrix. That means there is one row, but two columns in it. Again, first number is row, and the second number is columns. If you can remember that, matrix, multiplication, basic operations are super easy. Now, to add matrices together, matrices is the plural form of a matrix. They have to be the same dimensions, the same size. These two numbers that you're seeing here have to be the same for you to add or subtract them. If they're different in any way, maybe one number is off, and so the matrices look different, you can't add or subtract them. Multiplication is different, products. Scalar multiplication is completely different than all of them. So let's kind of jump in. I'm just going to show you, I think I have two slides here, two actual things, and I just have a couple of problems on each one. We'll just kind of pick and choose at some problems that are on there, so you can get basics like adding, subtracting, multiplying, and dividing, or multiplying, I should say, not dividing. All right, so I have a bunch of problems here, so you can see it. So I have an A, B, and C. You can add and subtract these. We can do all that stuff. But there's one matrix out of, there's one problem out of these three, A, B, or C, that you can't actually add or subtract. It's because the matrices are different sizes. So what I mean by that, it's not the variables or anything like that. It's the actual, dimensions that give it away. This one is letter B, if you don't know. This is a 2 by 3 matrix. That first matrix that you're seeing there. It's 2 rows and 3 columns. The second matrix is 3 rows by 2 columns. They don't match at all. So you can't add them, and you can't subtract them. So this problem is not possible. The weird thing is you could multiply these two matrices together. I know that seems really goofy, but you could. So we'll go into that. That'll be our one problem that we do by multiplication today, and I'll come back to that. All right, but let's take a look at adding here. So if I add matrices, so like on this top one, letter A, I can actually do this problem. So I want to add these two matrices together. You just add entry for entry. It's the easiest thing in the world. So in this case, if I'm going to add, my matrix will be the same size. I'm basically just going to add the first term and first term. First row, first column number. I'm going to add those two together. So 5 and a -8, if you add those together, you get a -3. The next one, I'll try to color code these. I'm going to add the 7 and the -3. Sorry, -7 and -3. I'm going to add those two together, so I'm going to get a -10. Let's change up the color again. On the other corner, I have a 4 and a 4. I'm going to add those together, so I get 8. And then the last one, if I switch up the color again, 6 and the 0. 6 and 0. I add those two together, and I get 6. That's your answer. That's it. That's matrix addition. You can even subtract them the same way. Front minus the back. You just subtract entry for entry. Super easy. So if you look at the bottom, I know that bottom one, they are the same matrix size. This is a 3-row by 3-column, 3-row by 3-column. So they are the same size matrices. I can subtract them, just entry for entry. I know it seems really goofy. So if I actually take that first item and subtract it, x plus y, and subtract it 2x, I'm going to get, let's see, I'm going to get a -1x plus y in that first spot, because 1x minus 2x's, so I get a -1x plus y. On the next one, I'm going to take a y and subtract another y, because I'm actually subtracting these matrices. So -1 minus 1, so I get -2y's. That's that next item. That's this one. Again, you have to keep track that you are subtracting these. So -1 minus y. So it's -1 minus 1. The next one is 1x minus 3x, so I get a -2x. There's the last column part. So that's the first row, all the columns. On the next one, I'll switch it up color here. I'm going 3x, and I'm going to be subtracting a -3. So if I subtract a -3, I'm going to be adding it. So 3x plus 3, so that's that first entry. The next one is -9 minus 12. So -9 minus 12, what is that, -21? You subtract that. Next one here, I have a -2, and I'm going to subtract a -5. So it's -2 plus 5, which is 3. Okay, I'll switch up the color again. And then the last one, -3x minus y. So we get -3x minus y. Because I don't know why I want that thing. Let me rate that. Okay, there we go. Just had to tap the screen. So -3x minus y. Next one is 4 minus x. Fine, 4 minus x. And the last one is 4y minus x minus a 2 minus a 3y. So I get 4y minus 3y, which is 1y. I have the minus x, and I have the minus the 2. And there's every entry. I know that they seem kind of goofy, but we can actually do that. Now, that's adding and subtracting. You just add you add the terms. The middle one I couldn't do, right? I couldn't add them. They weren't the same dimensions. But I can multiply them, do a product. So if they were to say, I'm going to change this. Let's say this problem was multiplication. Say they want me to multiply those two matrices together. I could do it. And the reason why multiplication is different, it's the way that it's done. It's not just entry for entry. I know that seems really goofy. Scalar multiplication is that way. You can take any matrix size and just multiply by number out front. So for instance, on this, I'm just going to take this matrix right here. I could put a 2 out front of that matrix and multiply every entry by 2. So the matrix would actually end up being a -16, a -6, a 8, and a 0, because I multiplied everything by 2. That's scalar multiplication. That's easy. But products are different. For you to able to multiply two matrices together, you have to have, so if I go to these matrices, this matrix is a 2 by 3, it's 2 rows, 3 columns. This matrix is 3 rows, 2 columns. This is how I remember it, how you can multiply. You look at the numbers for the dimensions, you look at the numbers that are closest together. If these match, if those two numbers match, you can multiply the two matrices together. That's how I know it. It doesn't matter where the other two numbers are. It's just the middle numbers that are closest together in the dimensions when you write the dimensions out. This tells me, yes, I can actually multiply these. Now, the crazy thing is the actual answer for this matrix, when I multiply them, will be 2 by 2. And you're thinking, okay, well, you circled 3s. Where are you getting the 2s? The actual answer will be the numbers on the outsides. It's very weird. It's very, very different when you see how multiplication works for the first time. And you really have to focus. It's one of those things that doesn't come easy to some people. So And this, again, we're going to focus on this one more in the next video, but I'm going to show you it now. This will be the intro to how to multiply two matrices together. So I'm gonna multiply these two together. So let me get rid of all these markings. Okay, so we're going to multiply these. So here's how it works. You're going by rows and columns. That's how I think of it. Row, column, row, column. That's how it works. So you do every entry. So now my matrix that I have written here is not probably big enough, but I'll try to make it work here. So I'm going to take the first row on that first matrix, the 5, the -7, and the 5. I'm going to multiply those individually on the column going down in the other matrix. So the 5 is times the -1. The -7 is times the 9, and that 5 is times the 10 in that row and column, if you can see that. Row, column, row, column, row, column. And what you do is whatever these numbers are, you're going to add those up. So I have 5 times a -1, a -7 times 9, and a 5 times 10. Whatever those answers are, I add those three up, and that'll be the answer in that corner, that number. So if I'm, writing this out, again, my answer will be a 2 by 2 matrix. -5 times 1 is -5. The -7 times 9 is -63, and then the 5 times 10 is 50. All right, so I'm going to add those three numbers up. So that first entry in the 2 by 2 matrix, if you type it in a calculator, I'm going to try throwing you off. Sorry, still had some numbers typed in my calculator. So -5, so 5 and it's negative. I'm going to add that to the 63 that is negative, and then I'm going to add a 50. So I got -18. -18. That's that number in the upper left corner. Now, I'm going to switch colors here. So my next one, same exact thing. I'm going the first row, the second column now. And that part is going to go, so if I transition my calculator here, sorry. Let's go back to my GoPro view. So the first row, second column, that is going to go over here. So first row, second column number. So this number here, so let me get rid of all this. There we go. That's going to go over here a little bit further. Okay. So first row, second column. So 5 times the -3, the -7 times the -3, and that +5 times the -9. That's the first row, second column numbers all multiplied. Now I know this, sorry, it's really hard to see that, but I'm going to write it down. 5 times -3 is -15. I'm going to add -7 times the -3 is +21, and then 5 times the -9 is -45. I'm going to add and subtract those numbers together. Now I'm just going to do it on the calculator here so I don't have to transition away from my screen. So -15 plus a 21 minus 45. There we go. And I'm getting a -39 in that next spot. So that's that second, the first row, second column number. Now, I'm done with that because I've already exhausted the entire top row, right? So I've done the entire top row of both columns. So now I'm moving on now, and I'm going on to the second row and doing the exact same thing. Second row, first column. So that's going to be the -2 times the -1, the 3 times the 9, and the -4 times the 10. So second row, first column. And that'll be that number in that bottom left corner. So that's what? +2 plus a 27 minus 40. So again, it's just that second row, first column, kind of getting those numbers, what I'm getting here. And hopefully those numbers are making sense for how you're looking at it. Typing this in, was that 29 plus 40, or minus 40, so it should be a -11. So we got a -11 there. All right, and the last one. Okay, so the last one, second row, second column. So the -2 times the -3, the 3 times the -3, and the -4 times the -9. So that should be a positive 6 minus 9 plus 36. So 6 minus 9 plus 36. I'm getting a 33 for that. And there is your final matrix. That's the matrix when you multiply them together. Now you're thinking, okay, Ward, why do we do this? Okay, think of it this way. Adding matrices is easy. It's the same concept of like, you go into a Word document or a Google Doc and you add words to it, right? And then you hit save and it saves quick. Boom, right? Saves instantly because you're adding a few more things. You're adding just, you know, pieces of two matrices that are matching. You add them together, they just add terms and they remember them. Multiplication for matrices is like you're copying it. You're copying all of your file into a different hard drive. It takes a while because you're copying row into this column over here, this row into this column over here, and it takes a while. It's like printing on a printer. It's trying to figure out where to store the information so it's perfect when it gets to the other side. And it goes one line at a time. Now it's going really fast doing it, but it's trying its best to go as fast as it can, but it's going perfectly. Row, column, row, column, row, column. And that's what it's doing in the background. Printers are the same way. They print a row, move down the column, row, move down the column, row, move down the column. That's why they used to be called dot matrix printers. It's one of those things like once you've been in computer sciences and you understand the concept of the way it works, it makes way more sense why computers take the time that they do when they get to certain tasks. Like adding to a Word document doesn't take very much, but copying a Word document to a different folder or to a different computer takes a while. Like when you airdrop something, it does take a little while because it's going from row to column, row to column, row to column, and it's trying to do it perfectly, very, very quickly. All information's there without being lost. So yeah, it's weird when you start to think about the concepts of why it's involved. All right, let's go to our last ones here. I'm going to get two more problems. I'm just going to do normal addition, subtraction. I think I've kind of exhausted the whole multiplication thing. But let's finish these up. These are my last problems here. We're going to be adding these two matrices for my fourth problem here. So if I multiply these, if I add these, I keep saying multiply. If I add these, I just add those, those separate entries. So 3 and the 6 will add to make the 9. The 12 and the 7 will make the 19. The 1 and 0 will make the 1. So there's your top row. The second row, the 1 and the 1 make 2. The 6 and the 3 make 9. The 5 and the 1 make 6. So there's your second row. Because again, I'm just adding entry for entry. That's how you add. And then the bottom row, this is 7. That's a 10 and an 8. So you're adding more to a Word document. It's really easy. It already has the file size perfectly. You just, you added a few things, and that's what it does, and it saves, and it's quick. Second one, you're going to subtract. So you're going into a Word document, you're editing, you're taking out some things, you're erasing some lines. Same thing. You're subtracting entry for entry. So 4 minus the 5, that's negative 1. 6 minus the negative 1, that's 6 plus 1. 8 minus 1, so there's your top row. 2 minus 3 is negative 1. 3 minus 5 is negative 2. Negative 2 minus 6 is negative 8. And the bottom row, negative 4 minus the negative 2, that's negative 4 plus 2, which is negative 2. Negative 4 minus 2 is negative 6. And, did I just get that one wrong? Hold on. Went too quick. 0 minus 2, which is negative 2. Wow, I almost really messed up there. And then the last one, 9 minus 10, which is negative 1. So you go. Sorry, entry for entry. Don't forget. I almost made a mistake there. So there you go. Entry for entry. But again, thank you for all the work that some of you are doing. If you're not submitting the Google form, that's fine. But try them out. Do the best you can. It's all voluntary. But remember, the first priority is your health and safety. Take care of each other, and I hope to see you guys real soon. Bye.